How to change the gain on your guitar pedal. But wait, this doesn't work for every pedal. This time, folks, we look at overdrive, distortion, and dirt pedals that utilize non-inverting op amps. Alright, so what we have here is the Vulcan Drive. It's been a little bit manipulated. We've added a couple of resistors and a switch here. We're going to go over in the schematic what's going on with that modification. But let's take a listen and see what audibly is going on. First, our clean tone. And let's take a look at light overdrive first. Alright, a little crispy, light. Now let's flip the switch. And do a little quick switching back and forth between chords. A little bit of crackle in between there. The solder job on this is a temporary thing, I promise. But here, let's actually take a look real quick on the PCB and see what we're actually getting. And then we'll look at the schematic. So what we got here is where there used to be a resistor here on R3, a single resistor. I broke it off to two separate resistors, and then it goes to a switch here, and from the switch it's actually going back into that resistor. So essentially what the switch is allowing us to do as we flip between back and forth is it's switching between the two resistors here for the negative feedback loop on this inverting op amp. So let's look at that as schematic, and let's do a little bit of math and see why we're getting what we're getting. Here we have a basic non-inverting amplifier. We have an op amp with 9-volt power and ground hooked up to it. And then we have a guitar signal coming in on pin 3, the non-inverting pin. We can identify the non-inverting pin on an op amp schematic because it has the plus sign next to it. The inverting pin, pin 2, has the minus sign. So why is this a non-inverting amplifier? We know it is non-inverting because the input guitar signal is on the non-inverting pin, pin 3. Unlike the inverting op amp, the signal will not invert from the input over to the output. And what this means is if I have a signal that starts on the upswing and ends on the downswing, the amplified signal will do the same. We know it is an amplifier because we will put a small signal on the input and get a larger signal on the output pin. The amount that it'll amplify is determined by its gain. We can determine the gain on a non-inverting amplifier by looking for the resistor values of RA and RB. The equation for gain of a non-inverting amplifier is RB over RA, and whatever that is, add 1. So let's do an example. If we were to take this one right here and change the value of RA's resistance to 1K, and then change the resistance value of RB to, say, 10K, that would be determined by going 10K over 1K, which is equal to 10. 10 plus 1 is 11, meaning we get a gain of 11. So by all standards and measures of Spinal Tap's Nigel Tufnell, this is a pretty awesome amplifier.
These go to 11.
If we put in a signal of 500 millivolts, or half a volt, peak to peak, multiply that by 11, and the output signal should be around 5.5 volts. Like an inverting op amp, we are limited to the supply voltage, and any gain that goes over the power rails will be clipped and distorted. So here we have the schematic of the pedal we were looking at earlier in this video. This is the DIY Guitar Pedals Vulcan Drive, which is based off of the MXR Distortion Plus. This premise isn't limited to this pedal, however. It also applies to the MXR Microamp, the ProCo Rat, the clipping stage found on an Ibanez Tubescreamer, the input stage on a Marshall governor, or any distortion, drive, or boost pedal that utilizes an op-amp in a non-inverting fashion. So let's find out the values of RA and RB to determine the value of its gain. We can ignore C3 in this example, as it is there to block DC voltage and help as an RC filter, and really doesn't pertain much to figuring out the gain of this stage. Originally, we had a fixed resistor for R3, which would have been used as our RB in our gain calculations. However, because I wanted two modes of gain, I substituted out R3 with a single pole double throw switch, which goes to two separate resistors, R9 and R10. And depending on the switch position, this will determine the value of our RB. As of RA, we have something a little bit different. We have two resistors in series, which means we need to add them together to figure out what RA is. One of these is a 1 mega ohm potentiometer set up as a single variable resistor. As I rotate this drive pot clockwise to turn up the distortion, the drive pot's resistance drops and brings in more ground up into R1. When the drive potentiometer is at noon, it's half of its total resistance value. So RA is R1 plus half of the drive pot, or 4.7K, plus 500K, or 504.7K. When the drive pot is dimed, we can practically ignore the drive pot altogether as it becomes 0 ohms. This makes RA simply 4.7K. So with the drive potentiometer dimed, let's look at RB again and figure out the gain. If we go through this way on the switch, where R9 becomes the enabled resistor, we have R9 over R1, or 220K over 4.7K, which roughly equals 47. Plus 1 will give us a total gain of 48. That's pretty big, and much better than Nigel's meager gain of 11. But we can do even better. If we go through R10 instead, we can determine the gain by going R10 over R1, or 2.2 mega ohms over 4.7K, which roughly equals 468. Plus 1, and it will give it a total gain of 469. This is a big amount of gain, and may lead us to think that the op-amp power supply rails may clip the guitar signal. But the hard clipping diodes on the output pin of the op-amp here will limit and clip the guitar waveform when it reaches somewhere around 700 to 800 millivolts peak to peak, before the power rails even get into the mix. However, if you wish to remove the hard clipping diodes to have solely clipping done from the op-amp, that's just a matter of removing said diodes. Lastly, let's talk about guitar pedal input impedance. One of the advantages to non-inverting op-amp gain stages is that you can use really low resistance values for RA to get a larger gain value, and then set the bias resistor to the op-amp independently, keeping a strong input impedance, which is usually desired. Whereas, inverting op-amps with a low RA used to make it a high gain amplifier uses that same low RA value to determine the input impedance, giving an inverting op-amp a low input impedance which may not be desired. This is what makes inverting op-amps very ideal for boosts. So basically, to change the gain on a guitar pedal using a non-inverting gain stage, simply find the values of RA and RB, and then increase or decrease the values to your taste. Anyways,
slap like now.
To let me know if you like these kinds of videos where we go over modifying and understanding pedal circuits, check out our store at www.DIYGuitarPedals.com, or click on the link below to order a DIYGP Vulcan Drive pedal PCB. Buying pedal PCBs from us keeps this YouTube channel going, and we appreciate every order we get. Thank you for watching, and cheers.